Hello everyone, welcome to IMS Gate Academy. As we know very well, in this series we started the ISRO PYQs and this is the last video of this series. Okay, after that from the next live session, means from the tomorrow, I'm going to start again the live course which we were already started, which is the foundation course. Okay, so the foundation course of engineering mathematics we are going to start from again tomorrow. We are going to resume, I will say. Okay, from tomorrow the timing will be same 6 o'clock, so you should not miss that session also. That is specifically dedicated to the GATE exam. Okay, although if you are preparing for ISRO exam, then definitely those sessions, those live sessions will be helpful for you also. Okay, so now let's start with the question. As we can see, we are having one question. It is asking about, consider the function fx is equals to x square minus 4 whole square, where x is a real number. Then the function fx has what? Only one minima, only three minima, only two minima, or none of these. So we need to identify here how many minima or maxima we are having. So the option is given to us. We can easily approach. You guys can try. Then I am here to solve the question for you. I am here to solve the question for you. So very simply, very easily you can try. We need to identify here how many minima or maxima we are having. So we can easily approach, dear students, this question. Yes, let's go for it. All right, so we are having a function. First of all, we will write down the function, what it is given to us. We are having a function as fx equals to x square minus 4 whole square. I can see this question is a maximum minima for one variable type of question. Okay, so I will find out. First thing, I can go with this one also, or I can just open this also. So this will be x square minus 4 to 8 x square plus 16. Okay, so this will be x power 4. I can write down directly. So for this function, I need to find out the first order derivative. When we will go for the f dash x, it will be 4x cube minus 8 to just 16x. We need to put it equals to 0. When I will put equals to 0, I can take common from here 4x. It will be x square minus 4 equals to 0. I can see my first root is x is equals to 0 and the next root is x square minus 4 is equals to 0, which can give me x is equals to plus minus 2. X square equals to 4 means it will be x equals to plus minus 2. Okay, so we are having these three roots because I am having x is equals to 0. When I am taking x common from here, it will be x square. 4 already we take outside, so x square minus 4. So we are having here three roots, 0 plus 2 and minus 2. All right, So what I need to check? I need to check whether on these roots I am having maxima or minima. So for that I need to find out double order derivative f double dash x. Let's find out f double dash x. So for this one, if I will find out one more derivative, it will be 3 4 ja 12 x square minus 16. On this one I need to put the value. Once when I will put 0, it will be negative. When it is negative means less than 0, hence here I am having maxima. When it is negative means less than 0, here I am having maxima. Let's check the value of the function at the given point, plus 2 and minus 2 also. When I will put here, either I will go with plus 2 or minus 2, it will be same, because we are having here as an x square, so it will be same. So 12 into 4 minus 16, I can see here I will have a positive root. Here I will have a positive root, so which is greater than 2 0. So here I am having minima. So I am having minima at x is equals to 2 and x is equals to minus 2 both. When you will check this one also, f double dash minus 2, here also we are having minima. When I will go for minus 2 square, it will be minus 16. Again it is positive, so it will be again greater than 0. So in this case also I am having minima. So what is my result? Look at the options. As it is mentioned, only one minima, only 3 maxima, only 2 minima, or none of the above. So I can see clearly here I am having one maxima at x is equals to 0 and 2 minimas at x is equals to plus 2 and minus 2. So my answer will be I am having 2 minima. So I will go with option B for Bombay, which is denoting only 2 minima. So I can go with this option very easily. Okay, so we can easily approach the thing, which is very simple. We can easily approach this thing. Okay, I hope this is clear to everyone. This is very simple thing which we can go. Okay, one very good question I am having before going to this one. I am having one question from ISRO 2008. Okay, one of the very good questions. So you can try the question and then we will have a discussion. So this question is from differential equation. So this is a very common pattern. This is a very similar pattern of question which we already see in the GATE exam. So let me write down the question. The differential equation satisfying as in this case solution is given to me. The differential equation, we need to identify the differential equation for this solution. So what is solution? Y is equals to a e power 3x plus b e to the power minus 3x. As the solution is given to me, y is equals to a e power, no, it is not minus, it is plus 2. A e power 3x plus b e to the power 2x. Okay, and the differential equation is, so we need to identify from here the differential equation. So the options are available for us. Let me write down the options. Okay, so my first option is d2y by dx2 plus 5 dy by dx minus 6y. d2y by dx2 plus 5 dy by dx minus 6y is equals to 0. Second option is d2y by dx2 minus 5 dy by dx plus 6y. d2y by dx2 minus 5 dy by dx plus 6y equals to 0. The third one is d2y by dx2 plus 5 dy by dx plus 6y. All are positive. d2y by dx2 plus 5 dy by dx plus 6y equals to 0. And the last one is both are negative. d2y by dx2 minus 5 dy by dx minus 6y equals to 0. So we are having very good question. We can approach the question very easily, as this is a question where solution is given to us we need to identify the differential equation among the option. If you want, you can go through the options also. If you want to go like this one, so what you can do now, first thing, as I can suggest to you, if you don't want to go directly, then you can means you, if you don't want to solve it, you can check one by one option by solving the equation, which equation is giving you the correct answer as a solution. Or you can go with the reverse mode also. So you can try, as I am here to solve the question very simply, very easily we can solve this question. This is a 2008 ISRO question. Very simply, very easily we can solve this one. Let's approach it. So we can solve first of all the question as we know very well. Suppose bachcho, I am having the equation like this one, a e to the power 3a or t, suppose b e to the power, it's not 3, suppose I am taking ax or bx. Okay, suppose I am writing in a general form ki if I am having a equation like this one, if I am having a equation like this, means the solution is written like this. If my solution is written like this, a e power ax plus b e power 3x, okay, b e power bx, then in this case my differential equation will be d minus a or d minus b. As we know very well, this a and this b is nothing but my roots only. This a and b is nothing but the roots only. Or if you want, you can write down directly the roots of the equation will be a and b. The roots of the equation will be a and b here. So we can go with the reverse like this. Ki in this case your equation will be d minus a, d minus b, okay, and y is equals to 0. We can make the equation, and from here by reverse multiplication, we can find out the equation. So in the same, this is the first method. Okay, second one is, as I told you, for by option. You can try each and every option. If the option is giving you this solution, then you can switch directly. Okay, now so here I can see what is given to me, as in the question it is given to me a e to the power 3x, b e to the power 2x. So I can see from here the a is equals to 3 and b is equals to 2. So literally my roots are 3 and 2. When roots are 3 and 2, my equation will be d minus 3, d minus 2 with y equals to 0. So I can find out my equation by multiplying these two things simply. When I will go for the multiplication, d into d is d square minus 2d, okay, d minus 2 minus 3d plus 6, okay, and overall y equals to 0. So I can go for d square minus 5d plus 6 or y equals to 0. So in this way, if you want to write down this is my final equation. If I want to write down this in a general form, so my general form will be d2y by dx2 minus 5dy by dx plus 6y equals to 0. d2y by dx2 minus 5dy by dx plus 6y equals to 0. Alright, so look at here, d2y by dx2 minus 5dy by dx plus 6y equals to 0, which I can see in option B for Bombay. This will be my answer. So I can go with this one very easily, as we know very well. We know this thing, and this is very basic thing also. If you approach the differential equation in detail, you know already we solved so many questions in the differential equation from here to here. But here I need to find out from solution to the equation. So we can go very easily, as in the solution part, these two will be nothing but the roots. So you can go with directly also, you can put the roots, and we can find out by multiplication the equation. This is my first method, as I told you. In the second method, if you want to go directly, then from each and every option you need to make, the second one is option elimination. So in this case you need to find out the solution of each and every differential equation which is mentioned in the option, and which whatever is giving you the solution as in the given question, that will be your answer. Okay, so we can approach the question very easily. The second I will not approach here, as I told you, I will go with the option elimination. So we can go by options also. Okay, now let's go to the next question. So A is an M cross N matrix. This is same get problem, same as it is. We are having get question of 1 mark. The only one difference is here, as it is mentioned A1, and in this case it was mentioned A star. In the get question it was mentioned A star. Everything is same otherwise. So A is an M cross N matrix with M is greater than to N, and I is an identity matrix. Let A1 equals to, what is given to you, A1 equals to A transpose into A whole inverse multiply with A transpose. This A1 is given to you. Then it is asking about which of the following statement is false. It is asking about false statement, not a true. So this is a very simple question. How we will approach? We will check here the left hand side and right hand side. If both are satisfying, if LHS is equals to RHS, then we will leave there only. That will be your answer, means that will be the true option. Here we need to identify the false one. So if LHS is not equals to RHS, that will be the false option. Okay. So but before approaching to the solution, you will try surely. So you can try, as this question is very simple question, you can try within the 1 minute you can solve a basic question, very, very simple question. Let's go for it. So this is a very simple question we can approach. We can see here A1 is given. So first of all, I will just simplify this A1 so that we can easily approach to the each and every option. A transpose A whole inverse multiply with A transpose. When I will open this one, I can see, dear students, that A1 is equals to, when I will open, as this is a very basic property of inverse, whenever I need to open AB whole inverse, it will open as B inverse into A inverse. That we know very well. Okay, the same property we use for the transpose also. If I am having AB whole transpose, it will open as always B transpose into A transpose. So both the things are same exactly. Okay, so here I can use, when I will open this one, it will be A inverse and it will be A transpose inverse, and here I am having already A transpose. And one more thing we know already, that A into A inverse is always is equals to I. A into A inverse is always is equals to I. Look at here, I am having A inverse transpose and A transpose, so both will become I only, multiplication, because both the things are same. So as if you want to write down only this part I am showing you here, A transpose inverse multiply with A transpose. So it will be nothing but 1 upon A transpose and multiply with A transpose. So these two things will be gone. We can write down directly the result as 1. So here also I can write down directly the result 1 very easily. So ultimately I am having A1 is equals to A inverse. From this conclusion, because this result will be I or 1. This result will be I or 1, right? So I can see my A1 is equals to A inverse. All right. So in the question at the place of A1, we can directly put in the question at the place of A1, we can directly put A inverse. Now let's one by one check the options. So let's start with option A. Let's start with option A. What is written in option A? A1, A. So A into A1, A equals to A. We need to check the left hand side LHS. When I will go with this one, A1, A. At the place of A1, I can put A inverse. So it will be A into A inverse or A. It will be nothing but I. So I into A is A only, which is my RHS. I into A is A only, which is my RHS. So this is so true. This is so true, dear students. So when it is true, we will just switch to the next one, because I need to identify here false. Okay. So this is true. Let's go for the next option, B option. So now I will approach here only. When we will go for the option B, let it be. Let's approach here. So when I will go with option B, as in the option B, I need to check left hand side and right hand side. So my option B is A1 square equals to A into A1. When I will check the left hand side at the place of A1, I can put A inverse. So it will be A into A inverse whole square. So which will be I only or 1. A into A inverse is 1 or I. So this is I. When you will put in the right hand side, this is your right hand side. When you will put here A into A inverse, so this is also I. So left hand side and right hand side are equal again in option B. So this is also true. I need to identify the false. So this is also true option. Option A is the true. Option B is the true. I need to identify the false one. Okay. Let's go with the option C. Let's go with option C. As from here I can conclude directly if option A is correct, then option D will be definitely false, because we already proved that option A means A into A1, A equals to A. So left hand side is same in the option A and option D. So when the left hand side is this one, the right hand side will be A. But here the right hand side is A1. So 100% this is the false. But why this is the false, I will show you with option C also. So option C, when I will check here, in the left hand side I am having A, I. So it will be A into A inverse, which is I only. So yeah, this is so true. So this one is also true. Now we need to check for this one, as we know already the result A1 into A will be equals to A, not A1. So this is the false option. This is the false option. I need to identify the false one. So this is my answer. I need to identify the false one. So if you want to check, you can put here A inverse into A. This will be I into A is A. This is my left hand side. And when I will talk about the right hand side, in this question, it is mentioned A1. So both the things are not equal. When it is not equal, it will be false. When it is not equal, it will be false. We can simply conclude it will be a false option. Right? Like this, we can approach the question. All right. Now, let's go for the next one. So, this is a simple thing. Cos Z can be expressed as options are given to us. We need to identify in cos Z. This is a question from the complex variable. So, the question is from the basics of complex variables. Okay. So, we need to identify how cos Z can be written in the given options. As the options are available, a very simple question we can understand by putting the values, means we can understand directly. So you can try the question, very simple question of complex variable. Let's approach it. A very simple question. We can go with this one, as it is given to me cos of z. Okay, I need to write down my answer in the form of e power iota z, e power minus iota z. The options are available. So what we will do, we will approach here. Cos z we are having, can I write down like this? 2 multiply and 2 divide. I can go with multiplication of 2 and division of 2 here. Okay, so it will be 1 by 2 is outside, 2 cos z. Now 2 cos z, can I write down like this? Cos z, because I can see one very simple thing. I can observe one very simple thing through the options, that in every option it is mentioned iota. In every option it is mentioned iota in the form of iota. Options are given to us, but right now we are having only cos z. So we need to write down the question in the form of iota. So I need to add here the terms of iota. So the cos z I can write down as cos z plus iota sin z. Okay, this I am having already, plus cos z minus iota sin z. When I will open, I can see from here iota sin z and minus iota sin z will be cancelled out. Ultimately, I will have cos z plus cos z 2 cos z. Okay, so that's why I will write down my question like this one. I will write down my question like this one. So this part, as we know that cos z or cos theta plus iota sin theta will be nothing but e to the power iota theta with the Euler's form that we already learned in the complex variable. So I can use same technique here, 1 by 2. This will be from here to here, it will be e to the power iota z, and from here to here it will be plus e to the power minus iota z. Okay, so this will be my answer, 1 by 2 e power iota z plus e to the power minus iota z. So this will be my simple answer. Look at the options, 1 by 2 e power iota z plus e power minus iota z we are having in option A for Ahmedabad. We can see the result in option A for Ahmedabad. Here we are having 2 iota, no it is not possible. Here negative, no it is not possible. 2 iota, not possible. So my result will be option A, which I can see very clearly, 1 upon 2 cos means cos z plus iota sin z we are having. So this will be e power iota z plus e power minus iota z. Very easily, very simply we can approach the question. Now I hope the thing is clear to everyone, a very simple thing. Now let's go for the next question, which is asking about the curl. So this question is from the vector calculus, which is asking about the curl of the given vector function. So when vector function is given to you, yz iota plus 3zxj plus zk, then we need to identify the curl of v, curl of this v. So simply the question is, as the points are not given to you, so we need to write down the result as simply only. And when we talk about the curl, so we need to identify the cross product only. Ultimately we need to identify the cross product only ultimately here. So just go for it, dear students, just go for it. Let's go for it. Okay, so it is asking about the curl. We will find out the curl. So v vector is given to me y z I cap plus 3z x j cap plus z k cap. Okay, I need to find out the curl. So curl of v vector means del cross v vector. So it will be I j k del by del x del by del y del by del z, and the functions are yz, 3zx and z. Okay, let's approach it. So when I will go with this one with respect to I, first of all I will approach. When I will go with respect to I can see I need to solve this one. So when I will go with partial differentiation of this z with respect to y, it will be 0 shunya, and partial differentiation of this 3zx with respect to z, it will give me 3x. So minus 3x. Okay, minus j. When I will go with this j, so partial differentiation of this with respect to z will be 0. Partial differentiation of this yz with respect to z will be minus y plus k. When I will go with the k, so I need to solve this one. Partial differentiation of 3zx with respect to x, it will be 3z minus partial differentiation of this one with respect to y, it will be z. Okay, so we can write down the result. Okay, it will be minus 3x I cap minus minus plus y j cap, or 3z minus z is 2z k cap minus 3x I cap plus yj plus 2z cap. This will be the curl of the function v vector. This will be the curl of the function v vector. So curl of the function v vector is this option A only. Curl of the function v vector will be option A, minus 3xi plus yj plus 2zk, minus 3xi plus yj plus 2zk. This is the simply answer we can approach. Very easily we can approach here. So this is asking about curl. The questions from vector calculus, we can see so many questions in the GATE exam also, because this is an important topic. So the same thing I can expect in ISRO exam also. So we can see questions from vector calculus also in ISRO. Okay, so the basic question from the Taylor series, it is given to us 1 plus x square by 2 minus x4 by 8 minus x5 by 15 and so on. This series is given to me, and it is asking about which option is satisfying this series. Is it the series of e to the power 10x, e to the power sin x, e to the power cos x, or e to the power x into sin x? Okay, so we can try. We need to check here. The only one approach we need to check here by options. So, and options also you can approach smartly. Options also you can approach smartly in this case. Yes. All right, let's approach it. So first of all, I can see I'm having here e to the power 10x. I don't think that this is a question where the series expansion is for the 10x, because now if I will take option A, because here I need to go with options only, option elimination only. If I will take, suppose my function is e to the power 10x. If this is e power 10x, I need to find out f dash x. So it will be e to the power 10x and sec square x. So I don't think it will give me the result as 1, because we need to put, here I need to use the Maclaurin series or the Taylor series at x is equals to 0. So you can write down the series which I will use. Fx is equals to f of 0 plus x minus 0 f dash 0 by 1 factorial x minus 0 whole square by 2 factorial f double dash 0, and so on we will going on. Okay, so when I will go with f0, when I will put here 0, means in this one only, in the function, when I will put 0, it will not give me the result. So I don't think it will work. Okay, even when you will put here in the derivative 0, so it will be e power 0 is 1, but this will be not working. So I think so this option and this option will not work, because here I'm having e power x and sin x, and I'm sure that it is not a function where we are having two things together, e power x and sin x. So as my intention or my intuition is saying me that either it is a e power sin x or it is a e power cos x. Either the question is of e power sin x or e power cos x. So I can eliminate A and D option. I will try with B and C directly. So let me try with option B and C. So let us try with option B. Option B, we can take the function as e to the power cos x. When I will go with f dash x, okay, I will put the values here only. So it will be e to the power cos x, differentiation is minus sin x. When I will put here f double dash x, okay, two more we will find out. So it will be, we can try it directly from here also, f0 e to the power cos 0. So this will be e power 0 is, cos 0 is 1 only, so cos 0 is 1 only, so this will be e. So I don't think it is satisfying again. I need in the series I am having the very first element as 1. So when I will put here, dear students, I can see the option B will also not work. Option B will also not work here. Okay, so the B is also not. Let's try for the C. So when I will try for the option C here, I can write down my function as e to the power sin x. Okay, so the first order derivative f dash x will be e to the power sin x. The differentiation of sin x is cos x. Let me try for the 0, f0. It will be e power 0, which is 1. Okay, I'm having first thing. Let's try for the second also, f dash 0. When I will go with this one, this is e power 0, which is 1, and cos 0. Cos 0 is 1. I'm having e power sin x. I can see my next term is x here. Okay, so I can see here where it is, this one, e power 0, cos 0 is 1, so again this is 1. Cos 0 is 1, e power 0 is 1, so again this is 1. We can try for this next term also, f double dash x. F double dash x means here now we are having two functions. First we need to solve e power sin x, and then we need to solve cos x. So e power sin x, differentiation of e power sin x is e power sin x, and the sin x of the differentiation of sin x is cos x. So we are having 2 cos here, cos square x, plus now the differentiation of cos x is minus sin x, and e power sin x will be as it is. So I can take here the value f double dash 0, cos 0 is 1, so e power cos 0 is 1, e power 0 is 1 only, so this will be 1, and minus sin 0 is 0, e power 0 is 0. So this I am having again as 1. You can see this is also 1. First order derivative is 1. The function value is also 1. I need to put the values there. So you can check if I will put the values in the Taylor series expansion, means the Maclaurin series or you can say the Taylor series expansion at x is equals to 0, or in general we use as a Maclaurin series only. So this can work as a Maclaurin. So fx is equals to f0 plus x minus 0 f dash 0 x minus 0 whole square 2 factorial f double dash 0 and so on and so on. So I can see f0 is 1 only, f dash 0 is also 1, so this will be x. Okay, and f double dash 0 we are having, as this is also 1, so this is x square by 2. Till now to I am having, I need to check one more. I needed to check one more. So if I will go with f triple dash x, so that why I am checking one more, because I need to check the sign here. The sign, the remaining signs are negative. So let's go for one more order derivative. So when I will go for this one, it will be e to the power sin x as it is, and the differentiation of sin x is cos x, so it will be cos of cube x. We are having already cos square x. Okay, and for the cos square x it will be 2 cos x minus sin x e power sin x. Okay, and one more term we are having as minus sin x or e power sin x. So for this also I need to solve. So when I am taking minus sin x as it is, the differentiation is e power sin x, or sin x is cos x. Okay, minus is this one, and plus the differentiation of sin x is cos x or e to the power sin x. Now we can check here by putting the value as x equals to 0. So when I will put here triple order derivative 0, it will give me 1. It will give me 2 cos. We are having here the sin 0 is 0, so ultimately it is 0. So this is 0 minus here we are having minus of sin x. So this will be 0 because ultimately we are having sin here, so it will be 0, and this will be minus 1. This will be minus 1. Wait a minute. We need the result as x cube by, the next term will be x minus 0 whole cube by 3 factorial f triple dash 0. Okay, so we are approaching for the triple dash only na. E power sin x, the differentiation is the e power sin x, differentiation of sin x is cos x, so it will be cos of cube x, and in the next we are having cos square, so 2 cos x, and this is minus sin x, and e power sin x we are having as it is. In the next minus sin x we are having, so the differentiation of minus sin x is minus, we can take outside, sin x will be as it is, e power x, differentiation is cos x, and the cos x, why I write down cos x, okay, this is the differentiation of sin x is cos x and e power sin x is as it is. Okay, so when I will go with this one, e power 0 and this is 1, I'm having here 2 cos 0 minus sin 0, sin 0 is 0, this will be, okay, this will be 0, here we are having minus 1, so the result is 0. The third order derivative is 0 here. Yeah, exactly the third order derivative is 0, because I can see here x power 4 is there. I can see in the result x power 4 is there. It is not having the, this is the function f of 0, this is f dash 0, this is f double dash 0, but here we don't have the triple order term, means here x cube is not there. So definitely we are going right. So this will be 0, and then we are having x power 4 by 8 and so on and so on and so on. Surely we are going approaching 100% right. So this will be my answer, which is option C for Chennai. This will be my answer, dear students, which is option C for Chennai. So if you want to find out more, you can find out more also. Okay, from here only I'm having my sense that when I'm having first term as 1, okay, second term as an x, okay, third term as x square by 2, okay, this is okay, and the fourth term as 0, and in this series also the fourth term is 0. So surely we are going absolutely right. Okay, so this is a good question. In this way, if you want, then you can find out for the fourth order derivative also, and you can check so on. Alright, so the basic question from Laplace transform, the Laplace transform of e to the power at cos omega t. So the basic question from Laplace as the same question, if you remember guys, we approached in the last session also, where we are having some terms, at the place of omega and a, where we are having some terms, few terms, means it was a, and it was, I think it was 2 cos 2t, and it was e power at. So the same question has been asked in the civil also, and this question is from the mechanical 2020. So we know very well, we need to find out here the Laplace transform of cos omega t first of all, and then we can approach. So what is the Laplace transform of cos omega t? S by s square plus omega square. Okay, if I will use here the shifting property, first shifting theorem, e power at hai. So at the place of, we are having e power at, at the place of s, I will use the opposite sign, s minus a. So using the shifting theorem, first shifting theorem, which is e power at cos omega t, I can write down, using the shifting theorem, I can write down, write down my result as it will be s minus a, the basic property we are having. This is s minus a whole square plus omega square. So which I can see in option A. So basically a simple question. The formula, only this is nothing but a first shifting theorem. So which we can use, first shifting property, which we can use very easily here. Okay guys, now let's go for the next. Okay, this is a good one. It is asking about, in a vector field, divergence of the gradient. If we are having a vector field, then what is the divergence of a gradient? If someone asks you what is the divergence of gradient, is it curl, is it unity, zero, or a Laplacian function? Is it curl, unity, zero, or a Laplacian function? So very easily we can approach. By the define only you can write down. By the define only you can write down the result. What is the result? You can easily write down. Yes. You can take any example as a function and then we can solve it. We can take any example. You can take the function as phi also, f also, anything. Yes. In a vector field, it is asking about divergence of gradient. So I can write down directly divergence. Suppose I am taking my function as phi. So divergence of gradient of phi. You are asking about divergence of gradient of phi. So divergence, if I will write down first of all gradient. This is my gradient. Now divergent is denoting del dot. The define of, if you know about this one, let me tell you. If I am talking about a function f, then the divergent of function f will be del dot f vector. And if I am having a function as phi, then the gradient of any function phi will be gradient of phi. I need to identify here divergence of gradient. Divergence of the gradient. So how I will approach divergence of gradient? So I will use divergence of gradient. So gradient, suppose I am taking for function phi. If I need to use this one here, I can easily write down. This is del dot del, which is del square only of phi. So this is nothing but del square phi. Del square phi means, if you will open this one, this is a Laplacian equation. This is nothing but a Laplacian operator. Del square is nothing but a Laplacian operator. If you will open, it will be del 2 phi by del x2 plus del 2 phi by del y2 plus del 2 phi by del z2, whatever it is we are having. Okay, so this is nothing but a Laplacian operator, which we can easily understand. Del square is Laplacian. Okay, very simply, very easily we can approach the question. Now let's go for the next question, and this will be the last question. So let's see what is the question. If a continuously differentiable vector function is the gradient of a scalar function. This is again a very good question. What it is given? If a continuously differentiable vector function is the gradient of a scalar function, then you need to identify its curl. You need to identify its curl. For what? A continuously differentiable vector function is the gradient of a scalar function. Okay, so I think it is asking about if I will tell you later. It is actually very simple thing. I will tell you later what it is asking. What it is asking, it is a very simple thing. The curl of gradient. The curl of gradient it is asking about actually. So you can take any function phi here again, and you can find out the curl of that gradient. You will get the result directly. You will get the result directly. As already we know, for one property, divergent of curl is 0 and the curl of gradient is also 0, but still you can try. Still, if you are having the same thing, then we will have a detailed discussion. As it is mentioned to us, if a continuously differentiable vector function is the gradient of a scalar function. So gradient of a scalar function, you can take any function phi for a scalar. Yeah, let's go for it. So I can see here, let me take the function phi xyz as a scalar function. I need to take a scalar function, na? So for that scalar we need to identify the gradient. All right. And what actually the question is asking? The question is asking about curl of gradient of this phi. Curl of gradient of phi we need to identify here. As we know already, the result is 0 because so many times we proved this identity. But still, I will prove here again for you one very simple thing. So I can find out first of all the gradient of my function phi. If I am taking phi as a function, so the gradient will be I del phi by del x, j del phi by del y, or k del phi by del z. This is my gradient of the function phi. I needed to identify here curl of gradient of phi. So it will be del cross del phi. Okay, this thing we need to identify. Del vector cross del phi. So I can write down this as an ijk. The del operator, del by del x, del by del y, del by del z. Now what is the gradient? Gradient is this one, this one, this one, and this one I will put here. So I will go with the del phi by del x, del phi by del y, del phi by del z. When I will solve this one with respect to I can see when I will solve with respect to I, the partial differentiation of del phi by del z with respect to y will be 0. So this is 0. Okay, again here this will be 0. Okay, plus j minus j. When I will go with j, for j, partial differentiation of this one with respect to x is also 0. This one with respect to z is also 0 because we are having opposite things here. And when you go for the k, partial differentiation of this one with respect to x is 0. Partial differentiation of this one with respect to y is 0. So ultimately we are having 0, 0, 0. So my final answer is 0 only. Everywhere I am having 0i plus 0j plus 0k. So the final result will be 0, my dear students. We can easily approach the thing. We can easily approach the question. Very simply, very easily we can go with this one. Okay, so as I told you, this is the last part of the ISRO PYQs. We already discussed so many questions from ISRO, for particularly ISRO. Okay, and we will continue our foundation course of engineering mathematics for the GATE 2000 next 2024. So if you are preparing for the 24 or 25, so if you are preparing for the GATE exam, you can surely watch the next session, which will start from the tomorrow 6 p.m. Okay, so you should not miss the session where we will continue the topic calculus. We were discussing in the last one, limits, continuity, we already had a discussion, mean value theorem also we had a discussion. So we will continue about from the calculus. Okay, so you can continue watching the foundation course of engineering mathematics. All right guys, see you there tomorrow with the new session for GATE. Till that, take care. Bye bye. Thank you.